Welcome back. Today we take a look at page 341. Here we go. Okay, number 2. We know the whole circle is 360. And if the whole thing is 360, but this red arc here is 280, what's that leave for this one? Well, 360 minus 280 happens to be 80. So this arc is 80. And then by the definition of arc measure, the arc measure is equal to the central angle measure. So the measure of angle 1 must be 80. And please note the symbolism we use here, the little m for measure of, and the angle symbol, measure of angle 1 equals 80. We move on to number 4. So far it's not too tough. I know some might argue that the book is not printed well and this does not look like it's a diameter in the book, but it is. If this is not intended to be a diameter, then there's no way to even answer this question. So clearly the book writer's intended for this to be a diameter. So if that's a diameter, then we know that a semicircle is going to have a measure of 180. So if the whole thing is 180, and this is 130 from here to here, what's that leave for this arc? Well, 130 plus 50 gives 180. And then again, by the definition of arc measure, if the arc is 50, then the angle must be 50, so the measure of angle 1 is 50. And we've got it. And we move right on to number 6. For number 6, we have 2 diameters, there and there, that happen to be perpendicular to each other. Well, that means that since this is a right angle, then the measure of this arc must be 90. But of that 90, 35 of it's sitting right here. What's that leave for this guy? This guy must be 55. So that the 55 plus 35 can add up to 90. Well, if the arc is 55, then by definition, the central angle must be 55, so the measure of angle 1 is 55, and we move right along. Number 8. There are several ways to look at this. One way is to say, well, I know the whole circle is going to be 360, so what is each hour? If the whole circle is 360, take 360, divide by 12 hours, and you end up with each hour being 30 degrees. We have a 30-degree arc, a 30-degree arc, a 30-degree arc. How many of those does it take to make 120 degrees? Well, if we come around to 4 o'clock and put the little hand there, we've got 4 o'clock. But it happens again on the other side of the clock, 30 degrees, 30 degrees, 30 degrees, 30 degrees, for a total of 120. So it also happens right there, little hand on the 8. So it happens twice a day, at 4 o'clock and at 8 o'clock. Actually, I guess I should say 4 times a day. 4 a.m., 8 a.m., 4 p.m., 8 p.m. There are other times when the angle is 120 degrees, but it would be very difficult to figure out exactly what those times are, because at different times, the hour hand is not going to be right on the numbers, and that presents considerable complications. But fortunately, they specified o'clock, which means the big hand, Mickey's big hand, is on the 12. And we move on to number 10, the multi-part number 10. I warned you in the previous video that this 2 here refers to this angle, not this one. Okay, so let's dive in. In the first column here, they give us the measure of arc CB is 60. Arc CB is 60. Well, if arc CB is 60, then by definition, what does that make angle 1? Angle 1 must also be 60. Now, to find angle 2, that's a little bit more tricky here. here's the key to it though. The key is this. What kind of triangle is that? Remember that in a circle, all radii are congruent. That's an isosceles triangle. And in an isosceles triangle, the base angles are congruent. This guy must be congruent to this guy. Ha-ha. So now, remember that old theorem from chapter I don't remember what, that says when you have a triangle, like this red one, with an exterior angle, that exterior angle, which we know is 60 degrees, has to be equal to the sum of its remote interiors. Well, the remote interiors are congruent because it's isosceles, because these are both radii of the circle. So if these base angles are congruent and have to add up to 60, what are they? Well, there's not much of a choice. They have to be 30. There is another way to do that, of course. If this is 60, we know this has to be 120 because these two guys have to add up to 180. And if that's 120, what's that leave us for these two? Well, these three have to add up to 180, so that means these two have to add up to 60. But if these two have to add up to 60, but they also have to be congruent, then they must each be 30. Now, that same reasoning will tell us, for the next column, that if arc CB is 70, then angle 1 must be 70, and angle 2, if angle 1 is 70, that would make this guy 110. And if that's 110, then these two have to add up to 70. And because they will be congruent, they have to be 35 each. Do you see a pattern developing here? That the arc is the same as the central angle, of course. And then angle 2 will be half of that central angle. Angle 2 is half of that central angle. Oh, angle 2 is half of 56. Yep. Which is going to be, in this case, 28. And of course, if the angle is 56, then the arc, by definition, is also 56. This is now getting too easy, isn't it? If angle 2 has to be half of angle 1, and angle 2 is 25, angle 1 must be 50. And again, of course, by definition, if the angle is 50, then the arc has to be 50. And now, here, they're trying to ask you basically, did you see the pattern? The pattern is, whatever this guy is, you double it to get that guy. Whatever this guy is, you double it to get that guy. And then angle 1 and arc CB will be the same measure by definition. Done. Done. What they're doing here, they're giving you a sneak preview into what's coming in a later sections of the next section or a couple of sections from now. There's another important theorem we're going to be getting to later, and they're trying to get you to see this pattern because this pattern is going to become a theorem a little later on. Well, that's it. That was a short assignment. I know what you might be thinking. Oh, I didn't understand number 10 at all. Number 10 was a little bit tricky. You simply had to recognize that because these guys are both radii, that makes it an isosceles triangle. Once you realize you got yourself an isosceles triangle, and you remember that the base angles must be congruent, from there it all falls together very nicely. But if you didn't see the isosceles triangle here, because all radii of a circle, all radii, including this one and this one, all radii of a circle are congruent. If you didn't see that, then you're kind of going, I don't have any idea how to do this one. Yeah. You have to think. Look for the patterns. Apply old knowledge. Actually, that's not so old. That was just back in section 9.1, that all radii of a circle must be congruent. Okay, that's that. So next thing we're going to be looking at is section 9.4 coming up in the next video.
See you later.